Hi, welcome to the WTAMU Virtual Math Lab. This video will step you through College Algebra Tutorial 20, Example 2. In this example, we want to solve the equation x to the 2/3 power minus 2x to the 1/3 power equals 3, which is quadratic in form. In step 1, we want to write the equation in standard form. An equation is quadratic in form if it can be written as a times some base being squared plus b times that same base plus c equals 0. It looks like we need to move that 3 over to the other side. We can do that by doing the inverse operation and subtract 3 from both sides. When we do this, we get x to the 2/3 power minus 2 times x to the 1/3 power minus 3 equals 3 minus 3, which will simplify to be x to the 2/3 power minus 2 x to the 1/3 power minus 3 equals 0. Let's rewrite this to show you how it fits into the quadratic equation. We can think of this as the base of x to the 1/3 power being squared minus 2 times that same base of x to the 1/3 power minus 3 equals 0. So it is x to the 1/3 power, that is the base that we were working with here. In step 2, we want to substitute a variable in for the expression that follows b in the second term. Let's go ahead and use the variable t for this. Since we have this written in standard form, then t is going to equal x to the 1/3 power. Next, we need to substitute t in for x to the 1/3 power in the equation in standard form. We have a base of x to the 1/3 power being squared, so when we substitute t for x to the 1/3 power, we will get t squared minus, and substituting t for x to the 1/3, we get 2t minus 3 equals 0. Because we started out with an equation that was quadratic in form, we now have a quadratic equation to solve. In step 3, we need to solve the quadratic equation created in step 2. If you need a review on solving quadratic equations, feel free to go to College Algebra Tutorial 17. Since this quadratic does factor, let's go ahead and solve by factoring. Factoring the trinomial on the left side, we get t minus 3 times t plus 1 equals 0. Since we have a product of factors set equal to 0, we can use the zero product principle and set each of these factors equal to 0. Setting the first factor equal to 0, we get t minus 3 equals 0. And setting that second factor equal to 0, we get t plus 1 equals 0. In the first equation, we need to do the inverse operation and add 3 to both sides, which will give us t minus 3 plus 3 equals 0 plus 3, which will simplify to be t equals 3. In the second equation, we need to do the inverse operation and subtract 1 from both sides, which gives us t plus 1 minus 1 equals 0 minus 1, which will simplify to be t equals negative 1. Even though we have found two values, we are not done yet. Keep in mind that we are finding a solution to the original equation and that the variable we substituted in for in step 2 is not our original variable. We still need to find what x is equal to. We need to do step 4, which is to find the value of the variable from the original equation. We can use the substitution that we used to set up in step 2 and then solve the original variable. In this problem, t equals x to the 1/3 power. Let's see what x is when t equals 3. Substituting in a 3 for t, we get 3 equals x to the 1/3 power. It looks like we have a rational exponent equation. The inverse of raising x to the 1/3 power is to raise both sides to the 3/1 or third power. When we do this, we will get 3 to the 3rd power equals x to the 1/3 power raised to the 3rd power, which simplifies to be 27 equals x. Next, let's see what x is when t equals a negative 1. Substituting in a negative 1 for t, we get a negative 1 equals x to the 1/3 power. Again, the inverse of raising x to the 1/3 power is to raise both sides to the 3/1 or 3rd power. When we do this, we get negative 1 raised to the 3rd power equals x to the 1/3 power raised to the 3rd power, which simplifies to be a negative 1 equals x. Even though we have found two solutions, we still want to do step 5, which is to check the solutions. In some cases, you will be working with rational exponents and square roots in your problems. Those types of equations can cause extraneous solutions. Recall that an extraneous solution is one that is a solution to an equation that, after doing something like raising both sides of an equation by an even power, but is not a solution to the original problem. Even though not all of the quadratic and form equations can cause extraneous solutions, it is better to be safe than sorry and just check them all. Plugging 27 in for x into the original equation, we get 27 raised to the 2/3 power minus 2 times 27 raised to the 1/3 power equals 3. 27 to the 2/3 power is the same as taking the 3rd root of 27, which is 3, and squaring it, which gives you 9 minus 2 times the 3rd root of 27, which is 3, equals 3, which simplifies to be 3 equals 3. Since this is a true statement, that means x equals 27 is a solution to this equation. Plugging negative 1 in for x into the original equation, we will get a negative 1 raised to the 2/3 power minus 2 times negative 1 raised to the 1/3 power equals 3. A negative 1 raised to the 2/3 power is the same as taking the 3rd root of negative 1, which is negative 1, and squaring it, which gives you 1. So we will have 1 minus 2 times the 3rd root of negative 1, which is negative 1, equals 3, which simplifies to be 3 equals 3. Since this is a true statement, that means x equals negative 1 is a solution to this equation. So the final answer is x equals 27 or x equals a negative 1.